Assalamu alaikum warahmatullahi wabarakatuh. Hi everyone, nice to meet you all. Today inshallah we will start together to explain what's the meaning of isotopes. We will start to answer some questions about isotopes and we will start to know together the hardest questions in isotopes for AS level in chemistry. Okay, I hope that you could understand our topic today. We will start to explain it step by step. Just stay with me from the beginning. Let's start together at first. What is the meaning of isotopes? To know what is the meaning of isotopes, we must know that in humans we have twins. Twins are exactly 2, 3, 4 or 5 persons. They are similar to each other, but we just have quite differences between our persons. For example, one of our twins is fat, the other one is thin. One is quite short, one is tall. So we are talking about twins. Isotopes in chemistry are exactly twins. But in our twins in chemistry, they are just different in their weight. They are similar but just different in their weight. For example, let's start with the chemical definition of isotopes. Isotopes of an element that have the same number of protons, but they are different in the number of neutrons. Sometimes you can find it written as they have the same number or atomic number, but they are different in their atomic mass. So we are talking about 2, 3 or 5 shapes of our element. The 5 shapes of our element are exactly have the same number of protons. They are twins, but they are different in the number of neutrons. They are unequal in their atomic mass. We want to understand this meaning more and more. Let's start to have carbon C612. Carbon C612 is written in the periodic table in the following shape. Why it is written in the periodic table in the following shape, although we have different shapes of carbon? Let's know the different shapes and the different twins of our element. At first, we have carbon 12. We have carbon 13 and carbon 14. So we have 3 carbon isotopes. The first one is C612. Second one, no, it is C613. The third one is C614. So we have 3 different isotopes. All of them are similar in their atomic number. All of our isotopes have 6 protons, have 6 as atomic number. But our atomic mass is different. We have C612, we have C13, we have C14. Number of protons in the first one is 6. Number of protons in the second one, 6. Number of protons in the third one is 6. Number of neutrons. How can we calculate number of neutrons? Number of neutrons is atomic mass minus the atomic number. So it is 12 minus 6 equal 6. So we have 6 neutrons. Number of neutrons in the other isotope is 7 neutrons. In the last one, it is 8 neutrons. So we have different number of neutrons. We have different nucleon numbers. In the periodic table, we have only one shape. We have only one element. Yes, we have only one shape. We have only one element because it is the average. It is the mass of the average of the three shapes of carbon, of the three different isotopes of carbon. So we have C6 12.011. From where 12.011? It is calculated from the average atomic mass of the element. How can we calculate its average atomic mass of the element? We will train it together right now. Okay. At first, we have mass spectrometer. Mass spectrometer, it is one instrument used for calculating the average atomic mass of any element. For example, I will take sample of carbon from the crust, just from the ground, and I will start to put it in our mass spectrometer. Inside the mass spectrometer, we will enter our sample. We will start to heat the sample at very high temperature till vaporization. When it converted into vapor, we will start together to make ionization. We will start to make ionization for the sample inside our mass spectrometer. By making ionization, the ions will start to move inside our mass spectrometer till we have magnet. Inside the magnet, we will start to make deflect. We will start to make separation for our ions according to their mass. For example, if I have three twins, if I have three shapes of my ion or my element, each one of them are different in their mass. One of them is thin, one of them is quite fat. So which one will be fast? Which one will finish the race at first? Of course, the thin one will finish the race at first. The first one to detect it on the detector is the least one in its mass. Then we will detect the higher one. At last, we will detect the highest. So, in our mass spectrum, from mass spectrometer, we will have the following shape. We will have relation about relative abundance, how common is the element in nature, how common is the element in the crust, and its mass to charge ratio. For example, we have zirconium as an example. We have 5 isotopes for zirconium. All of them are different in their atomic mass. The first one is 90, second one 91, third one 92, fourth one 94, and the last one is 96. So they are different in their atomic mass. The first one is thin, the last one is heavy. So they are moving in different speed. The first one will be detected at first, and its percentage in our sample is nearly 92. Second one is 91, and its percentage is nearly 12. Third one, 92, percentage is 16. Fourth one, 94, mass, and its percentage is 16. Last one, its mass is 96 and percentage is 4. How can we calculate its relative atomic mass? How can we write the element in our periodic table? Let's know how can we write the element in the periodic table. In the periodic table, we will calculate the relative atomic mass of the isotope is calculated by the following law, by the following relation. At first, the atomic mass of the first one times its abundance. First one atomic mass is 90, its abundance is 52. So it is 90 times 52 plus atomic mass of the second one times its abundance. So it is 91 times 12 plus the relative atomic mass of the third one times its abundance. It is 92 times 16 plus the same 94 times 16 plus 96 times 4 divided by 100. So we will find that the total relative atomic mass of zirconium is 91.32. It is quite similar to the published information, 91.224. So we can calculate the relative atomic mass of our isotope from the following relation. So we have some questions related to the calculating of relative atomic mass of isotope. How can we calculate the relative atomic mass of isotope? Take care, the value of calculated relative atomic mass must be in between the following values. It can't be forever less than 90 or more than 96. It is impossible to find it less than 90 or more than 96. Impossible. So cancel it. Okay? The second step. Take care. Your calculated value of relative atomic mass must be related to the mass of the highest element in the abundance. Let's look at our example. We have 90 is 50% and all the others is the other 50. So it must be near 90, not near 96. So if I calculated it 91.2 or 91.3, it is expected. But if I calculated it 96, impossible. Okay? Just try to calculate it by your mind. Okay? Let's have another example. Now try these questions are the questions in your Cambridge Chemistry book for AS level. Let's start with the first question. Chromium has 4 stable isotopes with the mass number 50, 52, 53 and 54 and relative abundance 4.3, 83.8, 9.5 and 2.4 respectively. Calculate the average atomic mass of chromium. We know to calculate the average atomic mass of chromium, we know a known relation equal to the atomic mass of element times its abundance plus atomic mass of another element times its abundance plus atomic mass of the third isotope times its abundance. All of these divided by 100. So let's start to calculate it together. Relative atomic mass of isotope equal atomic mass of the first one times its abundance plus atomic mass of the second one times its abundance plus atomic mass of the third one times its abundance plus the fourth one atomic mass times its abundance divided by 100. So our relative atomic mass equal. Let's start with the first one. Its atomic mass is 50 and its abundance is 4.3 plus second one 52, its abundance 83.8, third one 53, its abundance 9.5, Last one, 54. Its abundance 2.4. All of these divided by 100. Don't forget to write your practice in calculation. If you write the calculations without a practice, your calculation is wrong. And if your calculated relative atomic mass is less than 50 or higher than 54, you are wrong. If your calculation is far from 52, you are wrong. Why you are wrong? Because the abundance of 52 is 83.8. So you must be sure you are near 52 value. Our answer is 52.057, so it is correct. The next one. The mass spectrum of magnesium element. We have magnesium element, its abundance and number of isotopes and the mass of each isotope. The first one 24, second one 25, third one 26. And the abundance of the first one 79. So be sure your relative atomic mass is near 24. Second one 25 is 10. Third one 26 is 11. So to calculate the average relative atomic mass of our magnesium element to 1 decimal place. To write the calculation, at first the relative atomic mass of isotope, the atomic mass of isotope times its abundance, plus the atomic mass of the second isotope times its abundance, plus the atomic mass of the third isotope times its abundance, all of these divided by 100. The first one is 24 atomic mass and 79%. So it is 24 times 79. Second one, it is 25 times 10. Third one, 26 times 11, divided by 100. So the percentage of our isotope is what? All of these calculations will finish with 24.32. It is correct. I told you before, your value must near 24. Okay? Now we will start in the last example, and it is the hardest one. If you want to answer the following question, just think and understand my words. Iridium has 2 isotopes, okay, with mass number 191, 193, okay, and its average relative atomic mass 192.23. Okay, calculate the relative abundance of the 2 isotopes. We want to calculate the abundance. I told you at the beginning, I took one sample from the crust. For example, my sample is 100 grams. If I expect that the mass of the first isotope is X, the mass of the second isotope will be 100 minus X. Correct? I have 2 samples. Both of them are 100. One of them is X. The other one, 100 minus X. Okay? By using only this relation, we can calculate the abundance of the 2 isotopes, because we only have one unknown. Let's start to have the calculations. We expect that the abundance of the 2 isotopes is 100. We have 2 isotopes. The abundance of the first one is X. We have placed to save money at home. I add 5 pounds and my sister add unknown value. As total, we have 10 pounds. How many pounds did my sister add? She added 5 pounds. From where? Just 10 minus 5. So if I have the first isotop is x, the second isotop is 100 minus x. The relative atomic mass equal atomic mass of the first isotope times its abundance plus atomic mass of the second isotope times its abundance. All of these divided by 100. So AR of the element 191 times x, its abundance, plus 193 times 100 minus x, divided by 100. Just by using math calculations. 100 times 192.23 cross multiplication, we will have 191x plus 193 times 100, it is 19,300 minus 193x. So we just will transfer the numbers are calculated with each other and the other unknown values with each other. So we will transfer 19,300 to the other side with different charge. So by transferring it with different charge, minus 1933. 300. By transferring them to the other side, we have minus 77 equal minus 2x. Minus x equal minus 38.5. X equal 38.5. Just cancel the negative charge. Not more, not less. So we just cancel the negative charge. So the abundance of the first isotope, x, 38.5. The abundance of the second isotope, 100 minus 38.5, 100 minus x, correct? X is 38.5 equals 61.5. I hope that you understand our example today. I think it is the hardest example in the questions related to isotopes. Thanks for watching our video. Don't forget to make share and like for the video and make subscribe for the channel to have any new video. Thanks for watching. See you later. Assalamu alaikum wa rahmatullahi wa barakatuh.